Yes, I'm Sandy Thomson. I'm the founder of Thordon Bearings. I'm the third generation owner of the family business called Thomson Gordon Group. I came to the business in about 1967, and that's when I decided that we were going to move the company in a little different direction and look at making something for a polymer. And I was looking at three possibilities. One was a vertical pump bearing, another one was a flexible mount for machinery, and another one was a flexible coupling. And I looked at those three markets and decided to focus on the vertical pump bearing because there seemed to be less development work in that area. So that led me to what ultimately became Thordon. Now I had some help on that one. I had my uncle Bill, who was a chemist, and I had Dr. Pandey, with an Indian polymer scientist who worked with me, and the three of us, together with the person who did the work in the plant, we worked on developing a polymer that would actually function as a sleeve bearing. And we came up with Thordon. And the first product was a yellow polymer we called Thordon Regular. And then we came up with SXL, which was a white one, and it had a low coefficient of friction. Another one was a black one called Thordon XL. First application we put the product to was for a vertical scale pit pump at Stelco, the local steel company. We developed this polymer. We decided to try it in the scale pit pump at the steel company, put it in place of the rubber bearing, and lo and behold, it worked. And it did a better job than the rubber bearing. And that started us in business. And the first marine bearing that we made, the propeller shaft bearing, which was a little bit like a pump bearing except it was horizontal, was for a tugboat owned by the McKeil Marine in Hamilton. And they're now the largest tugboat owner in Canada. But in those days, they didn't have that many boats, and the owner of the company was McKeil, and I went to see him, and he finally agreed to buy a propeller shaft bearing and put it on his tug called the McKeil. That was the very first boat we ever had a bearing on. We put it on there, and it also worked, and everyone was happy with it. That really started the business. And then we started expanding into the international world. I made one trip to Sweden. We had our product tested by the Royal Institute of Technology in Sweden. They wanted to see if it was any good, and they tested it and made it fail. And they came back and said this product has absolutely no commercial potential because it doesn't work. Well, of course, you can make any test, make any material fail if you want to, and that's exactly what they did. You have to be careful that the test is realistic, and that's constantly a challenge for us in our R&D work, is making sure that our mechanical testing, physical property testing is realistic and it matches the application. So let's fast forward to the point where we developed Thordon Compact. Now this is a product that is very similar in chemistry to the Thordon SXL, the white one, but it's orange in color. And you'll notice that it has grooves for water lubrication only on the top and not on the bottom. Now, I have to admit that wasn't my idea. I was in London, England, talking to the folks at Lloyd's Register of Shipping, and one of the engineers there said, we've examined a lot of propeller shaft bearings that have failed over the years, and what we found is a couple things. One, that most of the wear is in the latter half of the after half of the bearing. So would your bearing, unlike a rubber bearing, would it support a load so that you could make it shorter? And I said, I think it probably would, but we need to test it. And the other thing he told me is, look, you got to have water flow through the bearing, and that's the reason why they put grooves in bearings. And typically they're all the way around the circumference, but why couldn't you just put them in the top and leave the bottom smooth, so that once you develop the hydrodynamic film, it'll stay there all the way through the arc of contact? I said, well, that's a brilliant idea. I'm going to try it. So we went back and we did some testing in the laboratory, and we built a test rig and we tested it, and we found that, yeah, we can make the bearing only half as long. And I can remember one of the rubber bearing manufacturers saying to me, Sandy, you're crazy. You're giving up half your profit. Why do you make the bearing half as long when you can make it 4 to 1 like everybody else does and sell it for twice the price? Well, our business has never been about making money for the sake of making money. Our business is based on doing something to make this a better world. We wound up making our compact bearings half the length of a typical rubber bearing. Compact bearings in a propeller shaft are extremely wear resistant, but they're also stiff enough to be able to withstand fairly high pressures. And they're also used in rudder bearings on vessels. If we really want to handle a high extreme pressure, we do it this way. This is called a Traxel bearing. Traxel, the name actually came from my daughter, whose name was Tracy. It still is. And XL, because that was what the first ones were. They were made from the XL material, so Traxel was the name. And we put a thin lining of Thordon inside of a metal shell. By making the lining thin, we increase the shape factor and we make it able to handle much higher pressure. And bearings like this can handle extremely high pressures. Although they don't have the wear down potential, they do have that capacity to take an extremely high pressure. And these are used in a variety of applications, wicket gates for hydro turbines, for example, and other extreme pressure applications. Thorplast came along later. That's a higher pressure polymer. Intrinsically, it can handle higher pressures, and in many cases, it's a cheaper option to the Traxel bearing. But this is still the highest pressure that we can take with any materials handled with this one. And so basically, that's the story of where it all came from. Now we've done a lot of development in the meantime, and we've we have a factory in Poland, in Swoops, Poland, where we're now starting to manufacture hydro turbines. We for years made hydro turbine bearings, and now we're making an entire turbine. And the idea there is to make a product that is environmentally totally clean and with extremely high efficiency and quiet. And so who knows what's going to come next? It's a business that's been going for 110 years. It's owned by my daughter Anna now. She's been in the business for about 20 years. It's still 100% family owned, and as far as I'm concerned, it always will be. Anyway, that's basically the story of Thordon, folks. And I don't know what it'll be in 20 years. Probably I won't be around to see it, but I think it'll be a good business.